In the previous lecture, we have started with elements of assembly language programming, in which we have seen what are the different features of assembly language programming. In that, we will see now a simple assembly language. In this lecture, we are going to see an instruction format and machine format of an instruction. So I, Professor Deepak Kosti, welcome you for this lecture. So let us start. Let us start with the first point, that is nothing but statement format. How the statement is there in assembly language programming. So assembly language statement has following format, that is label, that is as an optional. Whatever is given in square brackets is optional. Opcode compulsory. Operand specification, one operand specification is compulsory, comma, after that operand specification 2. Here it is written where content in the square bracket indicate that the enclosed specification is optional and label is a symbolic name. So this is how the statement format is there in the assembly language statements. Now what is operand specification? Now operand specification has the syntax as symbolic name and followed with if any displacement is there. Now what is that? Let us see. Symbolic name, that is nothing but operand specification. After that displacement is optional. The displacement can be area plus 5, area into bracket 4, area plus 5 into bracket 4. So what are these 4 possibilities? So you know, symbolic name area will refer to the memory word with which the name area is associated. Area plus 5 is what? It refers to the memory word 5 word away from the word with the name area. So area and plus 5 words away from area is seen and that will be referred. Area into bracket 4, nothing but operand addresses. Its operand address is obtained by adding the contents of index register to the address of area. Suppose address of area is 500. So into that 4 is added. So 504 is nothing but the address, new address, operand address that we are interested in. And area plus 5 into bracket 4 is nothing but going 5 words away from the area, calculating the address, and again adding 4 into that address, and then finding the content at that particular symbolic name is done by using area plus 5 into 4. Now I hope you understood that each and every symbol is nothing but an operand, and each and every operand is having an address, and by considering the address only, the instruction is executed. So this is what the statement format of assembly language statement. Label, then opcode, then operand specification, and then if any extra operand specification is there. That examples we are going to see, don't worry right now. Simple language is nothing but each statement has 2 operands. First operand is always a register in which any one of the following A register, B register, C register, and D register is taken. So each statement has 2 operands. First operand is compulsory a register. Now keep this in mind. If you have understood or if you have learned any other statement format, then for time being, for system programming subject, forget that particular statement format. Now here I am telling you, or here the author is telling you that first operand is always a register. Now you keep in mind, first operand is always a register. A register, B register, C register, D register. Now, second operand refers to a memory word using a symbolic name and optional displacement. So every time second operand is going to be a symbol. Either it will be with displacement or it will not be with displacement. Now, what are the different mnemonic opcodes? Now you can see here instruction opcode 00 to 10, assembly mnemonic, stop to print, and remarks what these assembly mnemonics are doing. So first is 00. 00 is nothing but stop. Remark is stop execution. Second is 01, add. 02 sub, 03 mult. So these are the second, third, and fourth instruction of code. What these are doing? First operand is modified and condition code is set. Now what this condition code is? Condition code is nothing but which is indicating that a particular register is occupied. And what these particular instructions are doing, add, sub, mult, these are modifying first operand. That means first operand is any one of a raised to b raised to c raised to d raised to, that will be updated with the operation which is given by the mnemonic. Next is opcode 04 and opcode 05, move r and move m respectively. So move r stands for move to register. Move r stands for move to register, and move m stands for uh, move to memory. Here some problem is there in remark. Move r stands for memory to register, move to register, and move m stands for uh, move from register to memory. So there is a mistake in remark. Just keep in mind there is a move r is nothing but memory to register, and move m is nothing but register to memory. 06 is comp. Comp means compare. Set condition code is set here. 07 is nothing but branch on condition, BC. For branch on condition, conditions you know, less than, greater than, less than, equal to, greater than, equal to, and not equal to. 04 is nothing but for division, same as sub, and 09 and 10 are nothing but read and print. Here for read and print, first operand is just eliminated because reading and printing of a register is not there. Reading and printing of a particular symbol is there. So operand 1 is eliminated. I hope you understood this instruction opcode. This mnemonic opcodes and assembly mnemonics you must be aware with, because this is required while converting assembly language code into machine language code. You can see here move instruction, move a value between memory word and a register. In the move r instruction, the second operand is a source operand and the first operand is a target operand that we have seen. Converse is true for move m. Move m and move r exactly in reverse. Condition code can be tested by BC instruction, branch on condition. BC, branch code specification. Now, and memory address. Then what is this branch code specification that we will see here? Branch code specification is nothing but the codes from 1 to 6. 1 stands for less than, 2 stands for less than equal to, 3 stands for equals, 4 stands for greater than, 5 stands for greater than equal to, and 6 stands for any. So this is how condition code is set. And then memory address. It transfer control to memory word if the address it transfers control to memory word with the address if the current value of condition code matches with the condition code. This is how the BC statement works. Then how the machine instruction format is there. The machine instruction format contains the parts as sign, opcode, and register operand, then memory operand. The opcode, register operand, and memory operand occupy 2, 1, and 3 digits. Sign is not a part of instruction, but it is indicating that this particular instruction is expanded or not. Sign, opcode, first operand, register operand, second operand, memory operand. So this is how the instruction format is there. Don't worry, we are going to see each and every machine instruction. Thus, we have seen what is the statement format, what are different mnemonic opcodes, and machine instruction formats. Thank you very much. This is the slide content, Dr. Damdere, and happy learning. Do subscribe the channel to get the new videos whenever I upload it. Thank you very much.